Okay, guys, greetings. First of all, this is just a work through of this test review. If yours says like this one midterm or quarter three, if it doesn't quite match up with what you think, this probably just means that I haven't changed the actual copies. But it's the same thing. Let's take a look at these things. Data was taken for 2 restaurants for a 1-month period of time. Assume all customers had an equal chance of going to either restaurant. And I'm being asked fill in the blanks on the two-way table. I want to pull out my calculator for this second. So I'm going to look at this, and I know that all of these should add up to this. All of these will add up to something that's missing. All of these will add up to so forth. So I'm looking at these. I know these two numbers, so I can take 4,205 and I can subtract 412, and that gives me 3,793 there. Oh, I can add these two together. I kind of just go in what order I see it. If I add these together, that'll give me that total. So 3793 plus 913. I'm going to put that in my calculator. And I get 4706. 4706. Oh, not 40. 4706. Okay, and if I add that to the 713 plus 713, so I add these together, I get this number, 5419. 5,419. Okay, oh, if I take this and I subtract this, I'll get this total. So 5419 minus the 4,205, that gives me 1214. And if I take 1214 minus 913, I end up getting that piece. Now, you may have done it in a different order, but this is what the table should look like. Cool. So, it says for problems 2 to 4, answer the problems using your finished table. So this one from problem 1. Build a Venn diagram. Okay. Label your oval. So my Venn diagram is going to look like such. And I'm going to have 2 ovals. 2 ovals because I only have 2 values here and 2 values here. And when you're making your Venn diagram, you're going to pick one thing from this axis. So restaurant A, I'll choose. And then you're going to fix one thing from here. Let's go food poisoning. And it says poisoning, that's P. Okay. You would never choose like restaurant A and restaurant B. You never choose 2 values from the same axis. You choose one value from one axis and the other value from the other axis. And then when you start filling them out, fill out the middle first. This intersection. This is people that ate in restaurant A and they got food poisoning. So restaurant A and got food poisoning, that's 412. That's going to be right here. Okay, these people right here, these got food poisoning, but they were not in restaurant A. So got food poisoning, they weren't here, so they've got to be the restaurant B peoples, the 301. These here, they were in restaurant A, see it? They're in the restaurant A circle, but they didn't get food poisoning because they're not in that circle. So restaurant A that were fine, that's the 3,793. Now, the only thing left is outside that were neither in restaurant A and they didn't get food poisoning. So if they weren't in restaurant A, they're in restaurant B, and they didn't get food poisoning, I mean, they were fine, that's the 913. Now, notice something. The totals do not show up in your Venn diagram. It's only these little subtotals. Okay? Now, find the following probabilities. Okay, the probability that I got food poisoning, a P. Well, they got food poisoning. That was 713 out of 5419. Okay. Now, to change that to a percent, because it says express it as a fraction and a percentage, all you have to do is change the fraction to a decimal percent. So 713 divided by 5,419 gives me that. I change that. So 0.1315 So I'm going to go 13 point, and I'm going to just round everything to one decimal place. So 13.15 is that's 2%. Okay, the probability of A, well, restaurant A, there's 4,205 of those people out of the whole total, 5419. Remember, probability is the desired outcome over the total outcomes. So, and if I change that to a decimal, 4,205 divided by 5,419 gives me that fraction, which I changed to a decimal, and I get 0.7759, so that's going to be 776, so 77.6%. Okay, if I do the probability of A and P and B, well, that means they're in restaurant B and they got food poisoning. Well, that's 301. Only 301 were in B and they're in that, so it's 301 over the total 5419. Okay, and if I type that in my calculator, 301 divided by 5419 gives me that fraction, 0.055. So if I round that, I get 2 decimals over 5.55, so 5.6%. Okay, now conditional probability. This is the probability that they were fine, that's the F, given they're an A. So this is saying out of the restaurant A. So now I'm only looking at this restaurant A. So I'm only looking at 4205. So it's not out of everybody, it's out of just restaurant A. How many were fine? Well, that was the 3793. So if I do 3,793 divided by 4,205, I get that fraction, 0.902, so that's 90.2%. This last one, the probability that they ate at restaurant B given they got food poisoning. So now I'm only looking at the food poisoning people, so I'm only looking at these. So there's 713 of them, and 301 ate at restaurant B. So this is 301 out of the 713. Remember, when you're looking at conditional probabilities, these are the subtotals. I'm only looking at the people in A, only looking at the people that are passing. 301 out of 713 gives me 0.422 or 42.2%. Okay, which restaurant would you rather go to? Wow. Well, I'm looking at this, and of all the people that restaurant A, I'm looking at this, and justify your answer with at least 2 of your own probability tables with numbers that proves your opinion is correct. So I'm going to look at this and say, well, I want to find, well, I've already got the probability that they got poisoning. Oh, actually, you know what? Here's what I want to find. I want to find the probability that they got poisoned out of A, and I want to find the probability that they got food poisoning out of restaurant B. That'll tell me the percent of people that got sick out of restaurant A and the percent of people that got sick out of restaurant B. So if I do that, I'm only looking at restaurant A for this first one. So that's this 4205. So out of those 4205, 412 got food poisoning. Okay. Now out of this is out of restaurant B. So out of these restaurant B people. So 1214. So out of this 1214, we got food poisoning. 301 got food poisoning. Okay, so now I can look at these, and if I go 412 divided by the 4205, gives me 0.0979, so 9.8. So 9.8% of everybody that went to restaurant A got food poisoning. And if I look at this 301 out of 1204, that's 1/4. which is 25%. If I go to restaurant B, it looks like I'm more likely to get food poisoning. So, just right, which one would I rather go to? I think I'd rather go to neither, but A. And I would just say you're less likely to get poisoning if you go to A. And there it is. There's a couple probabilities that I made up, and there's reasoning. Now, a tree diagram. Build a tree diagram for the data above so that you can find the following probabilities. Probability that you were fine given you went to B. So the given, that means I need to do that as my first branch. So I'm going to have, this is branch A, and this is branch B. This given will always make the first set of your branches. So probably I went to A was, do I know that? Yeah, that was this 77.6. So 0.776. Okay. And then I want to look at the other outcomes. I went to A and I either got poisoning or I was fine. So poisoning, I was fine. Poisoning, I was fine. Okay. To build the rest of these, I need to find the probability they went to B. So to find the probability they went to B, I just go 1 minus this 0.776. I get 0.224. So this branch here is 0.224 probability. Now, out of those people who went to A, how many got poisoned? Well, actually, you know, let's just look at this. The fine given they went to B. So B and fine. The probability they were fine given they were a B. Do I know that? I don't. So out of restaurant B here, that's here. Out of restaurant B, right here, what's the probability they were fine? Well, that's going to be 913 because they were fine. Out of the 1214. Okay. Okay. Now, to find this probability, I'm going to multiply this times this. So if I go this 0.224 times this 913 over 1214, and if you change it to a decimal, you're going to get something really, really similar. I get 0.1685 or 16.85% or 16.9 if I stick with just one decimal. Okay, guys, and that is the first page.